Welcome to 2022 and to this YouTube channel where we discuss the most current of current events. Today we'll be covering a news story that is 6 months old at the time of recording. Unless you've been living under a rock, in which case a bunch of billionaires are trying to go to space, and one of them was Richard Branson, who basically flew up in a glorified plane, while his rival, Jeffrey Bezos, flew up in a massive dildo. And when I saw the news story break on Twitter, I saw that Branson only made it up to 86.1 kilometers, depending on what you're measuring his actual altitude at the time was. And when I saw that, I went, wait a minute, that's not space, and started writing a video because this is a good time, I thought, to talk to people about the edge of space. Where is? Now, if you're an insufferable nerd like I am, you start with the Karman Line, an absolutely arbitrary boundary marked at 100 kilometers above mean sea level. Branson didn't make it, Bezos did. His dildo reached 107 kilometers. And yet, Wikipedia continues to say that Branson is the first billionaire in space. What's going on? Well, it turns out that the answer to the question, where does the Earth end and space begin, is more complex than I expected. I just thought it was some arbitrary rule that some organizing committee came up with and everyone just stuck to it because we need standards. And then I remembered that the United States of America hates standards almost as much as it hates immigrants, and realized that, no, of course, there's going to be some drama. So this video is less about where the edge of space is and more about why it's hard to define where the edge of space is, and how we did it anyway, because it's important. So let's start with the basics. There are two major definitions. The first is the Karman Line, adopted by the FAI. No, I'm not going to say that in full and embarrass myself.
Fédération aéronautique internationale.
Defined at 100 kilometers above mean sea level. Judging by the name of the organization, you can tell that this is what the Europeans follow. The other definition is from the US Air Force, and they define it at 50 miles above mean sea level, or 80.47 kilometers above mean sea level, which is a not insubstantial difference. That's like 23 Burj Khalifas all stacked up on top of each other. But why? Like, I'd expect them to be close, but not exact. When I started researching this topic, I expected the US definition to be somewhere close to 100 kilometers, but just in miles, because fuck standard units, somewhere around like 60 miles. So, instead of looking at it from the perspective of a committee, let's start from the physics of it all. There actually is no boundary of space. So to answer the title of this video, no, Branson did not go to the boundary of space. Nobody can, because there's no such thing. Bye! It's not like you're in the atmosphere and then suddenly there's nothing but the empty void, no matter how much this picture of the Earth makes it look that way. I'm not gonna lie, my first smartphone game was Angry Birds Space, and I will blame it for causing all of this confusion. The atmosphere is densest at the bottom, where we are, and then it just keeps getting nearly exponentially thinner as you keep going up, but never really fully in a vacuum. Fun fact, the International Space Station is actually only about 400 kilometers high, which, while in space, according to both these definitions, actually still experiences a substantial amount of air resistance from whatever is left of the atmosphere there. So they have to keep pushing themselves outwards. And it is for this reason that I thought that both of these definitions were completely arbitrary. But this assumption was wrong, so let's talk about it. Generally speaking, when we're talking about aircraft and aeronautics, we're talking about these bad boys. They got wings, and the main force pushing them upward is lift and aerodynamic force. Something that can happen only when there's a ton of air around. However, the more you climb up, the less air there is, which means to stay up, you'll need a little something else. And spacecraft don't need lift to stay up. They're moving fast enough because of all of the explosions, and what holds them up is the centrifugal force. So that's a useful distinction, don't you think? There's one point where lift keeps you up, and there's one point where inertia keeps you up. So there has to be a switchover point somewhere, and bam, that's the edge of space. Theodore von Karman, the dude after whom the FAI definition was named, estimated what the altitude would be for this switchover to happen, and it was, very roughly, 100 kilometers. Let me give you an example. This is the X-15 aircraft, and it could technically fly all the way out to 108 kilometers. The reason why I say aircraft in quotes is because it couldn't take off on its own. It had to be flown up and then released because it was basically wings and a human attached to a rocket. There's as much aerodynamic control there as a car driving off a cliff. So what kept it flying were purely inertial forces. But the X-15 belongs to the US Air Force, so let's talk about that 50-mile definition. So at the risk of sounding pedantic, the Karman Line is specifically a definition of the boundary between Earth and space. The USAF definition, however, stems from something else. Who gets to be an astronaut? Okay, so while editing this video, I found out that there's been talks to change this because too many people are able to go to space now, so only the crew, so to speak, get to be called astronauts and the passengers don't. It's kind of like how a lot of people can fly in planes today, but only some people get to be called pilots and airmen. Back to the video. Why 50 miles? Because the atmosphere is made up of layers, and this is roughly where the mesosphere turns into the thermosphere, which is also usually the coldest part of the atmosphere. This pedantry is somewhat required because till 2005, NASA, an American organization, used the 100-kilometer definition. They switched because at that point, their vessels were carrying both civilians, who would be following the 100-kilometer definition, and military, who would be following the 50-mile definition. Just so the definitions match and the people in this oversized soda can don't end up not being called an astronaut because of some technicality, they also switched to the 50-mile definition. The reasoning, broadly, is to do with their definition of orbital and suborbital flight, because you can have a spacecraft that doesn't end up in orbit. And a lot of people believe that in order to go to orbit, you have to hit this altitude of 100 kilometers. More on that later. But the point is, you can still have suborbital spacecraft and still not see a lot of the atmosphere. A useful idea here is to think of air as what it is, a bunch of gas molecules. And if there isn't a lot of gas molecules around, then they're not going to collide with each other a whole lot. So if your gas is light enough, then gas molecules don't keep bumping into each other, but actually move freely in nice, long, straight lines. Insert social distancing joke here. Wait, what is this? 2020? This is free molecular flow. And when that happens, you can pretty much forget about lift because the overall atmospheric pressure can pretty much be considered zero at this point, at least in the context of trying to fly planes. You still can't ignore air resistance though. And where does free molecular flow happen? Roughly around 75 to 80 kilometers, which only further strengthens the American definition. America, fuck yeah! Okay, so what? This is just some arbitrary line drawing in a place where you cannot draw lines. Well, as many people who have gone to space will tell you, there are a lot of lines that humans draw that don't exist from outside. So it's time to talk about everyone's favorite topics, jurisdiction and politics. So each country draws a line on the ground, and ever since this motorized kite flew, the idea is that a country also controls the airspace within its borders, which basically means everything within the borders, no matter how high you are, belongs to that country. And if you're in there, you need to follow their rules. Shortly before getting bombed out of the sky. However, because of the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies, outer space is for all mankind and no nation can claim any part of it. I'm just being a dick. That's not what the treaty is called anymore. It's just called the Outer Space Treaty now. Just like how a switch flipped between aeronautics and astronautics, a switch has to flip between when something is within the boundaries of a country and where it is not anymore. And that is a boundary. And everyone has to agree on where the boundary is. Or you get... So there was a joke here about a region that's under some serious political tension right now, and it was funny when I wrote it, but just insert your favorite politically contentious region here for this joke. Ah, fuck, it ruins the entire bit. In space. And for the longest time, this wasn't really a problem, but now it has to be taken seriously since many countries are starting to be
spacefaring.
And border ambiguities like this is how wars start, and you don't want a war to start in space, guy. So far, these boundaries up in the air don't have any legal protections. The space shuttle missions, for example, is a NASA thing, a US of A thing. But while descending, they've been inside Canadian airspaces without permission, which is to say they were below 50 miles, which is decidedly not space. But it wasn't really enforced because... why would you? Till China does it, of course, and either the US bombs whatever it is out of the sky, or US drags China to court. In both cases, we'll have an answer to that question, and also possibly a war. Hooray! Okay, I've been talking a lot about these definitions and committees, but I haven't actually mentioned something important yet, which is that the FAI, the organization that uses the Karman Line, are also starting to reconsider the definition of the edge of space, because 100 kilometers actually also doesn't make a ton of sense. This video is already plenty long, so I'll give you the biggest reason why. The accurate Karman Line is in fact very close to 80 kilometers. If you read his notes and use the modern, more accurate values for the properties of gases and our atmospheric profile and do the same calculations he did, you would find out that the point where inertial forces take over aerodynamic forces would actually be a lot closer to 80 kilometers than 100 kilometers. America 1, Europe 0? So in conclusion, did Richard Branson go to space? I don't really care, but if you're asking the question, where is the edge of space? Well, it changes when we want it to change. Right now, I have no problems agreeing with the US definitions. Man, even saying that hurts my soul, and I don't even have one. I also thought that what matters is that everybody agrees on what it is, but even then, that agreement is going to be time dependent. When it becomes piss easy to fly out into the 100 kilometers line, it's going to feel less like you're actually going to space and more like this is just a really fast airplane. I bet when the first commercial airliners flew, it felt like we were almost touching the sky. Heck, we still call tall buildings skyscrapers, even though the tallest of them all is barely a kilometer tall. We're far from scraping the skies and we're far from scraping the stars, but it's a good thing that the communities involved in these standards and practices, as it were, keep a bit of an open mind when it comes to defining and redefining terms that are more useful from a public relations and legality perspective, but less so from a scientific perspective. Because remember, there is no edge. Yes! Okay, fine, he went to space. Are you happy now? Fucking like, share, and subscribe now.
This is ground control to Major